Hello everyone, I am Nakazigo Olivia and I'm working on an AI project that is it's all about tracking the attendance of students in class. So what I'm going to do now, what I've come to present the exploratory data performance of exploratory data analysis on my data set within the project. So the project that I'm working on, as I've told you, it's all about tracking the attendance of students who come to class. So let me first start with describing my data set. The data set that I'm working with, it's called human faces, and it comprises of many images, almost 7.2K plus images. So it comprises of images, many images basing on races, age groups, profiles, and many more. So while performing this EDA, exploratory data analysis, first of all, you have to import the libraries. So some of the necessary libraries that I imported, there is NumPy, Panda, Seaborn, Matplotlib. Yes. So this downer thing that you're seeing here, I was trying to read my data set, like was reading and loading this CSV file. So it brought this output, which you see here in a tabular form. So in the process of implementing or performing EDA on my dataset, I had to output various graphs, should I say graphs, illustrations, and one of them is the heat map. Though though my dataset, though, though my dat though my dataset only works with images, so it was really difficult for me to come up with an heat map. But what I tried, I got some sample data from a certain image data set. For a certain image data set, it's what I used to implement this heat map as you see here. Then when it comes to the correlation matrix, this correlation matrix it proceeds from the heat map itself as you see. Then explode. The box plot, I started with importing the I started with importing this library panda as feedback. So the main reason for the box plot, it's basically a standardized way of displaying the distribution of database data based on five number summary. So under this five number summary, there is the first quartile, there is the minimum, median, and the third quartile plus the maximum. Then as we continue, I came up with the outlier plot. Basically, this outlier plot, it tries to show the points that are at the extreme end of the regression line. Yes. Then yes, as earlier on as I told you, our this the data set that I'm working with, it's basically comprises of images, so it doesn't work with heat maps. So instead of heat maps, I had to implement silence maps, whereby the silence map, it shows the darkest part that contribute towards the model. It shows the lighter parts that contribute to the model in comparison with this. So when you run this whole code, it brings this whole picture. Furthermore, here, this database that you see, basically, I was trying to show the train data, like the data that I used to train my model. So it was, after writing the code, it had to display this code into arrays, the images into arrays, trying to put them into arrays in order to use it to train my model. Then here, for this code data splitting, what I mean, I was trying to split. Here we see data is being split into data is being split into text set and train set for it to be fitted into the model here within this code. So for this other slide, it shows the way I fitted my model, whereby the data that was split, it contains different layers. Within these different layers, each layer is trained and then tested, in order to show in order to show its accuracy at the end in the process of evaluation. And it's going to be seen in the next slide. Yeah, so here finally, as I conclude, here we see the accuracy of each layer. The first layer, it shows 93%, 0.9 accuracy. Then the second layer, 0.93 still. Then here 0.87, 0.70, 0.61. Then finally 0.9. So this evaluation of the validation said we're trying to see the accuracy of our train model, which is here. Alright, that's all for today.